two resistances are connected in series as shown in the diagram. What is the current through the 5 ohm resistance? And what is the current through R? What is the value of R? What is the value of V? Let's start off with the 5 ohm resistance. Here is a 5 ohm resistance. So resistance is 5 ohms and the voltage here is given as 10 volts. Voltage 10 volts. So immediately we can find the current by using Ohm's law. So for Ohm's law we know V equal to IR. Your V was 10, I we do not know, and the resistance is 5. So I will be 10 over 5, and that is 2 amperes is the current. So the current flowing here through this is 2 amperes. The same current will flow through R because 5 ohms and R are connected in series. So in the next step I'm going to write current through 5 ohms is 2 amperes. So when I take my next resistance, that is say resistance 6 volts, not the resistance for my next resistance, that is R. I don't know this R, but I know the voltage here is 6 volts. It is given 6 volts, and now I have calculated the current. The current in this is 2 amperes. I have calculated. Again I put Ohm's law. So according to Ohm we have V equal to IR. V was 6, the I is 2 amperes, and the R. So R will be now 3 ohms. So we calculated the 3, R is 3 ohms. What is the value of V? This total V here. Now this V here, we know it is in series. In series, V equal to V1 plus V2. So this V will be, our V1 is 10. Here we have V1 is 10 and V2 is 6. So 10 plus 6. So total V is 16 volts. An electric bulb of resistance 20 ohms and a wire of 4 ohms are connected in series with a battery. Draw the circuit diagram. So here I have a bulb, which I'm going to draw this. Say this is the bulb here, and a 4 ohm resistance. So this is my 4 ohm resistance, and this bulb here is 20 ohms. They are connected in series, so I'm going to connect them now in series to a battery. This is my battery of 6 volts. Find the total resistance. So that is simple. Total resistance will be, the resistance will be R1 plus R2 because it is series. So total resistance will be 20 plus 4. Total resistance will be 24 ohms. So this is one total resistance of the circuit. So we have done this. Current through the circuit. Now when we want to find current through the circuit, we always use for the second part V equal to IR, Ohm's law. The voltage in this is 6, we've seen here. This is 6 voltage. The current we need to find. The resistance of the circuit we saw is 24. So the current will be 6 over 24 equal to current. That will be 1 by 4 amperes is the current in the circuit. Let me mark this current here. So I know this current flowing here is 1 by 4 amperes. So I've calculated this too. The potential difference across the electric bulb. So for the electric bulb now, for electric bulb, now let's do Ohm's law for electric bulb. Now in electric bulb, we know the resistance is 20 ohms. 20 ohms. And we know also the current, we already saw that the current I is 1 by 4 amperes. See the current in the circuit. It's the same current, 4 amperes will flow through the bulb. It will also the same current I 4 amperes will flow through the resistance. So when I use now the formula, V here, V equal to IR. My V I need to calculate. My R is 1 by 4 and the R and your I is 1 by 4 and R is 20. So when I cancel, I get V equal to 5 volts. So the voltage across this here the voltage across is put it another color here. This voltage here, maybe in green, this voltage here is 5 volts. Now we go to the wire. Now the wire here, wire for wire, let's write down. We know resistance of wire is 4 here, 4 ohms. The current we know is 1 by 4 amperes. It's the same current flowing, it's a series. So V equal to IR. So V we do not know, I is 1 by 4 and this is 4. So V equal to 1 volt. So the voltage across 4 ohms of the wire is 1 volt. And have you noticed something here? That V equal to V1 plus V2. The total voltage was 6 here. This was 6, which is equal to voltage across the bulb, which was 5, and voltage across the wire, which was 1. In the circuit diagram shown alongside, find the total resistance and the current in the ampere, in the ammeter. So let's calculate first the resistance. So if we look up here, we have 5 ohms, and these two now, the 3 ohms and the 2 ohms are connected in series. So the total resistance for this will be 3 plus 2, and that is 5 ohms. Now if I'm to draw this diagram again, now here I saw the total resistance here, 3 plus 2 is 5. So when I do this, this total will be now 5 ohms. And I know this is already given as 5 ohms. Now 5 ohms and 5 ohms are connected in parallel. So let me write this. 5 ohms connected in parallel. So the resultant resistance here will be 1 by R, parallel formula, 1 by R1 plus 1 by R2. 1 by R, 1 by 5 plus 1 by 5. So 1 by R will be 2 by 5 and R will be 5 by 2, and that is 2.5 ohms. So if I draw this again, the whole diagram. So now this red is the resultant. So this resultant is come as 2.5 ohms. If I want to calculate the voltage of this, is 4 volts. We know the resistance in this case of this is 2.5. We want to calculate the current Ohm's law, V equal to IR. So 4 equal to I into 2.5. So I equal to 4 over 2.5. Go further here, 40 over 25 amperes. That is 1.6 amperes. For the circuit shown in the diagram alongside, what is the current through 6 ohms and the potential difference across 12 ohms resistor? To start with, we'll see that the 6 ohms and 3 ohms are connected in series. So the resultant of this will be 6 plus 3, that is 9 ohms. So let me draw the diagram again. So this resultant is of both. So I'll just mix it up here. And this will be now 9 ohms. Similarly, for the next one, we see that, we'll just draw this line, 12 ohms and 3 ohms are in series, which means the resultant there will be 12 plus 3, that is 15 ohms. So here I have, the resultant here, this and the red together, this will be 15 ohms. Now there's a battery here of 4 volts. Now look up for 9 ohms. For 9 ohms, the resistance is 9 ohms. The voltage for 9 ohms is 4 volts. See, this is the voltage. It is connected to this, right? So the voltage is 4. Potential difference is 4. So we do V equal to IR, that is 4 equal to I into 9, and I equal to 9 over 4. So the current flowing in this arm here, in this arm, current is 4 by 9, not 9 by 4, that's a mistake, it's 4 by 9. Now we'll find out the current flowing in the other arm, that is the second arm, for 15 ohms. Now for 15 ohms, we know resistance is 15, and here the potential difference is same, 4 volts. It is in parallel. When parallel, potential difference is the same. So V equal to IR, and here V is 4, your I we do not know in this case, and your R is 15. So your I now is 4 over 15. So let's mark that up. So here we'll put it in another color. So here we have I is 4 over 15. So when we go back and find out what is the current, so here see what is the I here, 9 by 4 amperes. So what is the current flowing through 6 ohms? Through 6 ohms, the current flowing, that was question 1, will be 9 by 4 amperes. It's not 9, it's 4 by 9. Here I made a mistake. It should be 4 by 9. This also here would be 4 by 9. Let me change it all over. Here also will be 4 by 9 amperes. Here also 4 by 9 amperes. So the current passing through both 6 ohms and 3 ohms is also 4 by 9 amperes. And when we come to this, the current flowing through this branch we already saw is 4 by 15 amperes. 4 by 15 amperes. So when I do for, I'll just do it here, for 12 ohms, the current is 4 by 15 amperes, and we need to find the voltage. So V equal to IR. So V, your I is 4 by 15, your R for 12 ohms, the R is 12, and then you will find your voltage, and that comes 3.2 volts. So the voltage across, this is the potential difference across 12 volts. We could also find the potential difference across this, across 3 here. Just put the formula V equal to I R.